All right, 3.5, last section of the chapter for chapter 3. This will also be the last lesson for the week. You will have review for a couple days after this lesson. Okay, so our probabilities using combinations. Okay, so this is a good real life question here. So to win Lotto 649, for those who don't know what 649 means, well, you probably heard of it, but it means to match 6 numbers out of 49. So you're matching 6 out of 49. That's where the number 649 comes from. So you have to match 6 numbers out of 49. If order doesn't matter, because it doesn't matter what how the numbers come out. Okay, so imagine you have a bunch of balls inside of a container, and they randomly shoot out one at a time until you get 6 of them. It doesn't matter the order that the numbers appear, just that they do. Just like bingo. If you're playing bingo to get a line, you can get that line, those 5 numbers. It doesn't matter what order they come, as long as you make the line. So let's do the first one. What is the actual probability of winning the lottery, especially Lotto 649? Okay, so the probability that occurs is obviously the number of ways that occurs over the total. Okay, so how many possible ways can you win the lottery? Well, there's only one way, and that's if you match all the numbers. So your numerator is just 1. So there's only one possible way that you can win the lottery. Okay, and that's if you match all 6 numbers. Okay, so one way over the total number of ways. So the total number of ways would be 49 numbers, and you are choosing 6 of them. So you get 1 over, so 49 choose 6 is 13,983,816. So they say it's a 1 in a million shot. Well, not really. It's actually 1 in almost a 14 million chance to win. So, 1 in 14 million. I usually tell a story about there was a group in the U.S. In the U.S., the lotteries get extremely large. The numbers they get hundreds of millions of dollars in a lottery. So a group actually went out and made every single combination possible. I don't know how many numbers were in the lottery, but they actually went out and made out every single combination so that they knew it would win. So once they hit the lottery, they submitted all the tickets and they actually won the lottery. But I'll tell you guys more about that in person when I see you next. Okay, so that's A. Now B. Okay, winning the second prize by matching 5 numbers. Okay, so this one's a little bit more common, but still difficult to do. So we want to match 5 numbers. So if you were to win, you would match 5 numbers out of the 6. So we have 6 choose 5. So out of the 6 numbers, you want to match 5 of them. And then you multiply by the remaining amount. So you want 5 out of those 6, but then you have to get one more number. So the one last number has to come from the remaining 43 combinations. So you're matching 5 out of the 6 winning numbers, and then 1 from the remaining 43 numbers. All over 49 choose 6. So I get 258 over 13,983,816. So 258 divided by 13. Sorry, let me see if I can reduce this. So I get 43 over Okay, and the last one there, matching 3 numbers for free tickets. So out of the 6 winning ones, so out of the 6 winning tickets, sorry, 6 winning numbers, we want 3 of them. Okay, but you still need another 3 numbers, so from the remaining 43, you get the other 3 numbers, and all over 49, choose 6. 6, choose 3 times 43, choose 3. So I get 246,820, or 13,983 equals 6. 246,820 over 13,983 equals 6. And this comes to a decimal 0.017 or 2 or 2%. So even getting a free ticket is actually very difficult. 2%. So if you bought 100 tickets, 2 of them would give you a free ticket. So that's kind of scary. It's a little bit sad. Or if you bought 100 lines, which would be $100. I don't know if it's $1 a line or $2 a line now. You would get 2 free ones. So very, very low odds in winning. All right. Next question. Okay, teacher randomly picks 6 students to present a project on the first day. If there are 13 females and 10 males, what is probably that an equal number of males and females are chosen? There are 2 males and 4 females. I put this example because it actually reminds me of university. On my first week at university, first weekend when I was my 4th year at university, I went to, I don't know what the class was called. I think it was reproduction. Anyway, so after the first day, the professor asked us to pick a topic to do the project on, which was our like 60% of our mark, something ridiculous, or 40%. And sure enough, had to present the next week. So the second day of school, I had to present the project worth. Actually, maybe it was 2 weeks later. 2 weeks later, it was worth anywhere between 40 and 60% of my mark. Actually, I did very well, so I was happy with it. Okay, teacher randomly picks 6 students to present a project the first day. If there are 13 females and 10 males, was probably an equal number. So that means we want 3 and 3. So out of the 13 females, we are choosing 3 of them times. So we're doing probability, so make sure we have to have a fraction. So 13 females choose 3, and then we have 10 males, and we are choosing 3 of them as well because we want an equal amount, which is 3 of each. All over the total number of ways you could choose them. So 23 in total, and you're choosing 6. So 13 choose 3 times 10 choose 3 divided by 23 choose 6. I get a 0.34 or 34% chance that it'll be 3 and 3. Okay, B, 2 males and 4 females. So 2 males, so we want 10 choose 2 times 4 females, so 13 choose 4, all over the total of 23 choose 6. So 10 choose 2 times 13 choose 4, divided by 23 choose 6. Oops. Let me do that again. 10 choose 2 times 13 choose 4 divided by 23 choose 6. I end up getting, I'm surprised this is lower percentage. I got a 32%. 10 choose 2 equals times 13 choose 4 goes divided by 23 choose 6. Yeah, let me double check the first one. I would have thought this would be a higher number because there's 4 females, females than males, so having 4 would be more common, but I guess not. So you get 32% for that one. Okay, and then on the last question, which says go to page 131, example 3. Okay, so what we have here, and the reason why I put this is because it's very difficult to draw out on the computer. So we have 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5. Okay, so Plinko. So we have a game called Plinko. So you may have seen this before, and usually where people see it is maybe at an amusement park. You might have seen this at Wonderland or a C&E, but the most common one is on The Price is Right. So Price is Right. I remember when I was younger, I used to like this one the most, which is Plinko. Not too sure why, but I did. So what happens is you release a disc. So a disc, and these are all little pegs. So this disc goes down and it bounces around the pegs until it hits one of these slots in the bottom. Okay, so usually they would have something like the grand prize in the middle, with on either side would be zeros, and then other amounts towards the ends. So it says, state the probability of the disc ending up in each slot at the bottom of this Plinko board. So we want to know what is the probability that it'll land in each of these. Okay, so we have to go and do the same process as we did for like Pascal's triangle. So if you drop this disc here, it has only a couple options to go. It could go down this way, so it could hit this peg and it could bounce here, or it could bounce there. Okay, so what happens is it has one option to go this direction and one option to go this direction. So it hits this peg and it either goes to the left or goes to the right. So you have one option to the left, one option to the right. Okay, and we're going to fill this in. If it keeps going down this way, it can bounce through here and over to the side again. So there's one way that it could go into this spot here. Likewise, on the other side, if it goes down this way, it has one way of going through there. Okay, but now we have to fill in the middle, just like we did for Pascal's triangle, because the disc can bounce here and then bounce here. Or it goes here and then bounces here. So then there would be two ways you could get to this gap over here. Okay, we're going to continue the pattern. So one way here, one way down this way, and then 3 here, and 3 in this spots here. So if you release the D disc at this spot here, no chance that it will go to A or F. So there's a 0 chance of going to F. 0 out of a total of 1, 4, 7, 8. So 0% or 0 to 8 chance that it will land in F, A or F. There is 1 chance that it will land in B, so 1 out of 8. If it's to land in C, it'd be C and D, it's 3 out of 8 for both. And lastly, for E, it'd be 1 way out of 8 outcomes it could land into E. Okay? So as for the probability for this one, that's why I did fractions. You could turn them into decimals if you like to. So it'd be 0%, 12.5%. What is this one? 37.5%, I believe it is. 37.5%, 37.5%, 12.5%, and 0%. I'm just gonna double check that answer in the back. Yeah, that's correct. All right, so homework then is page 132, numbers 1 to 4, 5 A, B, C, 6 to 8, 10 A, and 11. I put something in the star on 5B. Not too sure why. Number 6, there is another answer in the back now. I think I put the corrections. So just double check number 6. It's actually a very difficult question, number 6. Okay, and then the review questions, which will be for Thursday and Friday, is page 134, numbers 1 to 10, 13 to 17. Okay, that's the end of chapter 3. I'll see you guys later in the week.